This is number 11 from section 8.3 from the Bluman 9th edition book. So here it says television viewing by teens. Teens are reported to watch the fewest total hours of television per week of all demographic groups. The average television viewing for teens on Sunday from 1 to 7 p.m. is 1 hour and 13 minutes. A random sample of local teens disclosed the following times for Sunday afternoon television viewing. At alpha equals 0.01, can it be concluded that the average is greater than the national viewing time? So, and they gave us a note to change all the times to minutes. Well, okay. So it said that the average viewing for teens on Sunday, so this is my population mean, or mu, is 1 hour and 13 minutes. 1 hour, 13 minutes. Again, I'm changing everything to minutes. And I know that 1 hour is 60 minutes. So that means that 60 plus 13, that would be the total amount of minutes, which is 73 minutes. Okay, so this is my mu. Now, what did they tell us? They told us a random sample of local teens disclosed the following times for Sunday viewing. They gave us our alpha, confidence, so it's 0.01. This is our level of significance, which can also it's the complement for our confidence level, basically. So this is my mu, and this is my alpha, and it's asking if it can be concluded that the average is greater than the national viewing time. Well, let's see what they gave us. They gave us a set of data. We're gonna have to just obviously turn everything to minutes. Also, from this data, we can conclude our sample size. So it's 1, 2, 3, 6, 7, 8, 9. So there's 10, right? Yeah. So I know that my sample size, or n, is equal to 10. Okay, now I need to find other things. Mainly, I need to find my x bar, or my mean, and my standard deviation. I don't know why I did that. My standard deviation is just S, right? Because this is a t-test. I do not need. Actually, the requirement of having a t-test is that the population standard deviation is not given, and obviously here it wasn't given. And even from this data, we can only figure out our sample standard deviation. Okay, so let's find them. Well, let's pull out the calculator. So it's gonna be second. Or I think it's just stats. Yeah. So stats, no second, and then we go to edit. Let's clear our list. Let's go back, clear. Okay. I'm trying to figure out if I can do this. Okay. So now that I cleared this list, what I'm gonna do is I'm gonna enter these values. However, I have to turn them to minutes first. So let's look at the first value. Here, let's just mark up on the thing. So this is 2 hours and 30 minutes. Oh, let's see. Yeah, this is 2 hours and 30 minutes. 2 hours is 120 minutes plus 30. This gives me 150 minutes. So it's going to be 150 for the first one. Oh, I don't know why I did 150. Enter. The second one is just 1 hour, so that's 60 minutes. This one is 1 hour and 30 minutes, so it's going to be 60 plus 30, which is 90. Oops, 90. Okay, 2 hours is just 60 times 2, 120. It's basically 60 plus 60. And then 2 hours and 15 minutes, that's 120. Plus 15, it's going to be 135. 135. 2 hours and 30 minutes, that's the same as this one, it's 150. Nope, 150. There we go. Okay, and now 1 hour is 60, and then 30 minutes, so 90. And then we have 1 hour is 60 plus 50, that's 110. Here we can do, I think I can actually enter it. 60 plus 50. Yeah, it does it by itself. Okay, and then also, okay, so 3 hours is basically 60 times 3 plus 20. So this is 180 plus 20 is 200. We can check it. Let's do 60 plus 60 plus 60. That's 60 times 3 plus 20. Give you 200. And then 2 hours is just 120. And then plus 10, that's 130 minutes. So, okay, well, now I have everything. I'm just gonna open up. Okay. So now I need to, using this list, I'm gonna quit first, and then I'm gonna do second, or actually I don't even need to do second, I think it's just stats. Yeah. So go back. I'll go back, and then I just pressed stats right here under the delete button, and then calc, and I'm just gonna press the first option. It's gonna be one variable stats. I'm just gonna press calculate. So my mean is 123.5 minutes, and then my standard deviation is 39.3. Okay, so this is good. 39. Yeah, okay. So now what? Now I have all my data. I need to first construct my claim and my H naught and my H1. So H naught is that my mu is equal to 73, and then my H1 is my mu. Let's see what they told us. They said, can it be concluded that the average is greater than, so my mu is greater than 73, the national viewing time. Okay, so this is we did that already. Now let's just find our critical values. So we find our critical values from our alpha. We know that alpha is equal to 0.01, and also from our degrees of freedom. We know that n is equal to 10, so my degree of freedom is equal to n minus 1, which is 10 minus 1, it's 9. Okay, so I know my alpha, and I know my degree of freedom. Also, one more thing that I need to realize, this one here, they said it was my mu is greater than, so this automatically tells me that this is gonna be a one tail, specifically a right tail test. So it's just one tail. Okay, well, because of that, I'm gonna go here, and I'm not gonna look at my two tails, I'm just gonna look at my one tail. They gave me my alpha is equal to 0.01, alpha equal to 0.01, so I'm gonna have to go all the way across to that value. 0.01 is right here. And I also know that my degrees of freedom was 9. So let's just go down here. And now let's just see where they meet. So my critical value is 2.821. My critical value is 2.821. So this is this value right here. Okay, well, I found now my critical value. Critical value equals 2.821. Now, number 3 is I have to find my test value. By the way, if you guys remember, this would be here is the area where we do not reject H naught, and here we do reject, or just reject H naught. Okay, well, now it's time for us to find our test value. We know the equation for t is just going to be our x bar, which we already found. Give me a second. Our x bar we already found, it was what was it? It was 123.5, minus our mu, which is the 73, divided by S, or the sample standard deviation, divided by the square root of n. So this is just going to be my x bar minus my mu. It's going to be 123.5 minus 73 divided by 39.3 divided by the square root of 10, because there's 10. My sample size is 10. Okay, so let's just quit. And now I'm just gonna enter them. So it's gonna be 123.5 minus 73. Let's go back to. Okay, let me just make sure that we did this right. Calc 1 var stats. Enter. Yeah. Okay, everything's good. Second, quit. Yeah. Okay, so I'm just gonna do my x bar. Or actually, my x bar minus 73 divided by my standard deviation divided by the square root of 10. And I'm just gonna press enter. So I know my t value, or my test value, is 4.063. This, my 4.063, is gonna be to the right. Actually, let's redraw the normal distribution. Or let's redraw the distribution. So remember I said here, this is 2.821, and everything here is the rejection region. So I know that my test value was 4.063, which is somewhere around here. This is 4.063, which is obviously gonna be in the rejection region because it's a lot to the right of the 2.821. So from this we can reject. I'm just gonna erase this. So from here we can just reject the h naught. So we're rejecting h naught. Also, we said that the claim, this is our claim, I just forgot to specify that it's greater, because it's asking, can it be concluded that the average can it be concluded that the average is greater than the national viewing time? So this is our claim. And now we can look at the table to figure out how we can word our conclusion. So our claim is that our claim is h1, and we rejected h naught. So we can say that there is enough evidence to support the claim. So for my conclusion, last part, I'm going to say there is enough evidence to support the claim that what was it asking? Yeah, the claim that the average is greater than the national the national viewing time. And this is it. This is how you would word it, like, so that it's specific to the problem. So yeah, this is all for this problem. Thank you guys.